This is Sheikh Mohammad Mohit from ECE. Today my topic is statical independence of random variables. Introduction to statical independence. This presentation explores the concept of statical independence among random variables. Understanding impedance is fundamental in probability theory and statistical modeling. We will definition, properties and application throughout this presentation. Random variable defined. The random variable is a function that assigns a numerical value to each outcome in probability space. Random variables can be discrete or continuous depending on their possible values. They are used to model in various real-world phenomena. Joint and magnerial distribution. The joint distribution describes the probability of multi-random variables occurring simultaneously. The distributions are derived from the joint distribution by summing or integrating over other variables. These distributions are essential in understanding the relationships between variable conditional probabilities. A simple relation between joint and conditional probabilities. In fact, this is taken as conditional probability. What is statistical independence? Two random variables are statically independent if knowing the value of one provides no information about the other. If knowing the value of one provides lot of information about the other. Mathematically, independence implies the joint distribution factors into the product of distribution. Independence is a key assumption in many statistical methods and models. The value of one provides no information about the other of statistical independence. Formula definitions of impedance. Random variables x and y are independent if all x and y p of x is equals to x comma y times p of y is equals to y. This condition must hold for all possible outcomes in their support. When this is true, the joint probability distribution is a product of individual distribution. Independence for discrete variables. For discrete variables, independence means the joint probability mass function equals the product of the mass function. This simplifies calculation and understanding of variable relationships. Discrete independence is often easier to verify due to countable outcomes. Independence for continuous variable. For continuous variable, independence implies the joint probability density function equals the product of marginal density. Integration over the joint density confirm the impedance condition. Independence and conditional probabilities. Independence can be characterized using conditional probability. This is the occurrence of x does not influence the distribution of y. Properties of independent variable. Independence implies that the expected value of product equals the product of expected value. The independence of variable is zero, but the conversion is not necessarily true. Independence is a stronger condition. Independence and uncoordinates. Uncoordinated variables have zero coherence but are not necessarily independent. Independence guarantees, but the reverse does not hold in general. Additional conditions such as normality are needed for the converse to be true. Independence in multivariate settings. The random variables are mutually independent if every pair is independent and the joint distribution factors into the product of individual distribution. This extends the concept of independence to higher dimensionals. Mutual independence simplifies the analysis of complex systems. Testing for independence. Several statistical tests excited to access independence, such as tests for categorized data. For continuous variables, correlation tests or mutually information methods are commonly used. Proper testing depends on data type and distribution assumptions. Independence versus dependence. Dependence indicates some of relationship between variable which can linear or non-linear. Independence indicates the absence of any relationship. Recognizing dependence is crucial for accurate modeling and interference. Application of independence. Independence assumes are used in machine learning like algorithms such as classifieds. In financial independence assumption simplify the modeling of asset returns. In experimental design independence ensure unbiased estimate of effects. A few keywords of independence: sample space, random variable, discrete and continuous distribution, joint condition, statistical independence, limitation of assuming independence. The independence without verification can lead to incorrect conclusion. Independence in Bayes influence. A Bayes model often assumes between parameters to simplify computation. Independence and causality. Independence does not imply causality. Two variables. Thank you.